This is Pom and welcome back to the channel Safety with Pom. So in this today video we will discuss about the calculating the safe fall distance as per the OSHA standard. If you have watched my previous video, in that video we have discussed about the active and the passive fall protection system as per the OSHA requirements and other regulations that we have discussed on that one. In that video, I have informed you that I will let you know that how to calculate the safe fall distance before a person start to use a personal fall arrest system. So before you are allowing any person to use the personal fall arrest system in any work areas, it is very important to calculate the safe fall distance to avoid any injury. Okay, so that's why I have prepared this video, so it will be very helpful for you to get this information and implement in your work areas as well. So let's start the video. Before starting this video, I would like to request that please subscribe the channel if you haven't subscribed the channel. Please like the video and share the video and comment in the comment section and let me know how you find this video and which part of the world you are watching my video. And if you need any other support or any other training topics that you would like to me to prepare and share with you, do let me know as well. So let's start the video about the safe fall distance as per the OSHA requirements. Before starting this video, to calculate the safe fall distance, we have to understand what is the meaning of safe fall distance. So let's go through this one first. So as per the OSHA, safe fall distance refers to the minimum vertical distance required to ensure that a fall arrest system can stop a fall safely before the worker strikes a lower level or obstacle. So OSHA doesn't define a single safe fall distance, but it says that it has set some standard for fall protection systems and minimum clearance required based on system design. Typically, OSHA haven't said that what is the minimum clearance you have to maintain, or so OSHA not saying that 2 feet, 3 feet, 2 meter, 3 feet, 3 meter. So it is not typically they are saying that how much distance you have to maintain, but OSHA says that minimum safe clearance distance you have to maintain. So as per the definition, as per the OSHA, like let's say that the person is working at this point, and when the person is fall to the floor vertically, so before the person is striking to the floor, you have to maintain a safe distance. Okay, so how to maintain that safe distance, you have to calculate. So there are some things, there are some different criteria that you have to follow, and you have to calculate the full things. Only then you will come to know that what is the minimum or maximum clearance that you have to maintain to avoid any accident or incident to the person. So OSHA safe fall distance calculation, there are some criteria that you have to follow, and before that we have to go through those criteria as well. So as per OSHA's fall protection standard 29 CFR 1926-502, which is for construction industry, and 1910.140, which is for the general industry. So it is required that worker must not contact a lower level during a fall. So how we can make sure that worker will not contact with the lower level during a fall while the person is using the personal fall arrest system? To check that one, we have to calculate few things. Okay, what are those things? I will let you know. So the first thing, we have to check the free fall distance, FFD. Now what is the free fall distance? Free fall distance is the distance a worker falls before the personal fall arrest system starts to arrest the fall. And when the person fall, before the personal fall arrest system start to arrest, this should not be more than 6 feet as per the OSHA requirement. If the person fall more than 6 feet, then you are violating the OSHA requirements. Okay, so let's understand how it's work. FFD, free fall distance. So let's say that the person is working here. Okay, now, and the person fall from here, from this line. Okay, person working here, and after this person fall here. Now this distance, now when the person fall, this personal fall arrest system activated. Okay, so it is activated when the person fall. So when the person is fall and the system personal fall arrest system activated, this length, vertical length, distance should not be more than 6 feet. It is the OSHA requirement. Okay, so that we have to follow and make sure that this free fall distance should not be more than 6 feet. Then we have the deceleration distance, DD, the distance needed to stop the fall after the system engages. Okay, once this system engaged, system activated, personal fall arrest system activated, person has to stop completely. Okay, down here, person has to stop completely. Now, when the person fall and after the system engage, so OSHA says that limits should not be more than 3.5 feet. Once the person fall here, okay, then person come to the deceleration distance and the person is completely stopped. After that level, person will not fall down more. So when this complete stop happen here, this length shouldn't be more than 3.5 feet. Okay, as per the OSHA requirement. If person deceleration distance is more than 3.5 feet after the fall, then you are violating the OSHA laws. Okay, to avoid that thing, you have to make sure that person is not falling more than 3.5 feet. So this is the deceleration distance. Then harness stretch and D-ring shift. Allow about 1 foot for the webbing to stretch and D-ring movement. So when the D-ring is moving here, okay, so D-ring is here. So webbing stretch and D-ring. So webbing is there and the D-ring movement. So webbing stretch and D-ring movement should not be more than 1 foot. Okay, that is the harness shifting. Then the walker height below D-ring. So in this one, there is no OSHA requirement. The height, it could be depend on the worker. It could be 6 feet, it could be 4 feet. It depends on the worker. What is the height of your worker? So that height also you have to add. Then the safety margin. In this one, OSHA doesn't say that how much safety margin you have to maintain, but they are saying that clearance you have to maintain, safe clearance distance you have to maintain. So it could be 2 feet, it could be 3 feet, 4 feet, 5 feet, and it's up to you as per the design of your area. Now, there are some formula that we have to use to calculate the safe fall distance. So first, free fall distance, okay, it is 6 feet, should not be more than 6 feet as per the OSHA requirement, okay. Then we have the deceleration distance, it is 3.5 feet, it should not be more than 3.5 feet. Then the harness shift, it is 1 foot, okay. Then the height, worker height, it could be 4, 5, it's depend on your worker. Then we have the safe margin that you have to maintain. So you have to add all of these together. Then whatever your answer will come, whatever the number will come, that number will be your answer, to make sure that this 17 feet or 17 foot, that distance you have to maintain a safe fall distance. Okay, now let's understand this one by example. Let's say that free fall, as we know that free fall distance is 6 feet, it will remain same. Then the deceleration distance, it will also remain same, 3.5 feet, it will not change. And harness stretch, it will remain same, 1 feet, it will not change. Now the worker height will change, it could be up, it could be more, less or more, it could be 4, 5, 6, 7, 8, it's as per the worker height. Then the safety margin, it's up to you, how much you want to maintain, 3 feet, 4 feet or 5 feet, it's up to you also, that is also changed. Now once you get all these data, all these number, you have to add all these number like this. Okay, this is the formula that you have to use to calculate the safe fall distance. Once you calculate, it's saying that 17.5 feet, the safe clearance distance you need to maintain to avoid any injury when the person is falling from the height, while the person is using the safe fall, personal fall arrest system. Okay. Now let's understand this one by an image. Before a fall, 6 feet length of linear, 3.5 feet deceleration distance. This is the free fall distance. Okay, this is the deceleration distance, and the worker height is 6 feet. Let's say that the worker height is 6 feet. Now here you are maintaining the 3 feet safe distance. After then you will calculate, you will add all of these as per the formula. Then the total distance is required is 18.5 feet from anchorage. Okay, so in this way you have to calculate the safe fall distance. Now there are some tips that you can follow to maintain the safe setup. Okay, first of all, use the shorter lanyards. The longer the lanyards, the length the lanyards will more, the injury, the risk will be more. So I would suggest you to use the self-retracting lifelines, which is available nowadays in the market very easily, like this one, so that you can use. So it will stop the fall, okay, and it will reduce the length of the lanyards also. And the position of the anchor points overhead to minimize the fall distance. It is also very important where you are positioning your anchorage. I would suggest you it should be always on top of the head. Then always conduct a site-specific fall clearance assessment before you are allowing any person to use personal fall arrest system. Always check the fall clearance assessment. Okay. After you conduct the fall clearance assessment, only then you will come to know that what is the safe clearance distance that you have to maintain. Maybe 1 meter, maybe 1 feet, maybe 2 feet, 3 meter. It's depend on that one. So I would suggest that always conduct a site-specific fall clearance assessment. Only then allow any person to use the person fall arrest system, and only then you give a permit to work in that areas. Okay. So that's all from my side on this video. I hope you understood that how to calculate the safe fall distance, and I hope this video will help you in your work areas also. And please do not forget to share this video with your colleague and other people also, so they also will get the benefit from this video. So thank you so much from your for your time and your support. See you in the next video.